All right, so again, that's what you need to have for today. Please have it at the ready. Those of you watching on the line, you will need to have those 4 things in order for this, along with extra paper for taking notes. All right, so we are going to start trig today. Woo! It's what we live for here in pre-calc. Trig, chapter 4. We love it because then chapter 4 leads to chapter 5, which is good stuff. Chapter 5 leads to chapter 6, which is even better stuff. Okay? All based off of trig. Okay? So, normally we would have in like an algebraic function, we would have a function based off of x. And that x would be numbers that we could plug into the function and we would get out a value, and that would be our output. Okay? So our domain would be the x values and our range would be the y values. Okay? Trig functions have angle measures as the input. So the angle measures are now your domain on a trig function, and the output is a real number. Okay? So no imaginary numbers in trig functions. Okay? So our output is real numbers, so our domain is angles, our range is real numbers. Okay? So we have 2 different units of measure. The first one is degrees, okay? And we use 360 degrees to go all the way around a circle. Why 360 degrees? Well, it is the sexagesmal, or I don't even know how to say that word, and I'm a math guy, okay, counting system, where it's a base of 60. 60 is kind of one of those cool numbers, okay, because so many other numbers can evenly divide into it. 1, 2, 3, 4, 5, 6, 10, 12, okay, all of those can, 20, 30, all those, there's many numbers that can divide into it. Whereas if we went with just base 10, let's say, if we were talking about if we went base 10, it would just be 1, 2, 5, and 10. And not a lot of things can go into it. 60 has a whole range of things that can go into it. And even a number like 8 can not necessarily evenly divide into 60, but it ends up being 7.5. So that's an easier type number. So that's why 60 is such a nice number. Okay? So some of the measures that we have. Now here is where life in trig starts. Okay? So you need to wrap your mind around the fact that over here on the positive x-axis side, that is where 0 degrees lies in trig. Okay? So that's the 0 degree mark for trig. For positive values, for positive angles, we will go that way around our circle. Let me actually bring this back up a little bit more now. Here, come on now, there we go. Let's get it up. There. Okay? So halfway around the circle would be positive 180 degrees. If it's 360 all the way around. Half of half would be 90. Half of half of half, half of half of half, yep, would be 45 degrees. this one then would be 135 degrees. 90, 180, 270 would be straight down. 225 would be the halfway point between 180 and 270. 315 would be the halfway point between that one. Okay. So that's the positive direction. We also have the negative direction. We can go around the circle in a negative fashion. So then this would be negative 45 degrees, negative 90 degrees, negative 135 degrees, negative 180 degrees, negative 225, negative 270, negative 315, negative 360 degrees. We have positive and negative angles in trig. God, I love this stuff. So that's degrees. Okay? So 360 to go all the way around. If we have a degree measure bigger than 360, we go all the way around the circle. And so if it was like 540 degrees, we would start at 0 still, go all the way around to 360, and then end up over here at 540 degrees. Okay? We can just go on the same, we can go multiple times around the circle. Okay? Now, that is one of the units, degree units, or excuse me, units of measure is degrees. Now, this is where we're going to need all of your materials for today, because we are going to now do the Smarties lab. Okay? So, on a fresh blank sheet of paper, what you need right now, a fresh, clean, blank sheet of paper. Okay? Right smack dab in the middle of it. Okay? Right in the middle of it, I need you to put a dot in the middle of your paper. Then, if you can, because everybody has a different sized circular object, okay? If you can, what I would like you to do is I would like you to try and line up 7 of your circular objects butting up right against each other in a straight line. If you can't, if you're using bottle caps or buttons or something that's a little bit bigger, do as many as you can to get to the as close to the edge as you possibly can. Okay, so as many as you can going out from your dot. If you can get more than 7, that's great. You can use more than 7, but if you can't get all the way to 7, go as many as you can. Okay. Now, if you have a compass, you could use the compass here. If you don't have a compass, that's where a piece of string or a headphone cord or something along that realm comes into play, okay, or a charging cord or something like that. So with if you're left-handed, use your right hand. If you're right-handed, use your left hand. Grab your cord at some point in time in it, and put that where you grabbed your cord, put that end right on your dot. Okay? And then wrap your cord around your pencil on the other end. So it looks like this. So you're holding it kind of like this. Okay? So your fingers are going to go on the dot, and you're going to extend your cord out all the way to the end of your circular objects. And then what I'd like you to do is I would like you to attempt to draw a circle around that is the radius of your circle, if you will. Okay? I have the luxury of having a compass, if I can find it now. There it is. But I have properties. I'm going to go into properties and change my color. Or not. Okay. Okay. So now what you can do is put your marker back on there. Now what you can do is let's delete that. We don't need that anymore. Oops, shoot, we do need that. I need this, but I need it over here. I just need it away. Okay. So now what I would like you to do is somewhere on your circle, doesn't matter where, I would like you to put an X or a big old dot. If you actually know, oh yeah, you can put a dot. Okay? An X or a dot, it doesn't matter to me what you put on your circle. Huh? What I would like you to do now is I would like you to take your radius, so that is whatever your circular objects are, and it doesn't matter which way you go around your circle, but I would like you to line them up on your circle going all the way around. Okay? Now you're not going to be able to do it very easily, or I shouldn't say you can't do it all at one time. Okay? So you get your 7 lined up on your circle, and then you make like let me get into a different color here. You make like a line, or another X would be okay on your circle. And then you're going to repeat that process. Whoa, tap the brakes. You're going to repeat that process all the way around your circle. Okay? So do that now, please. Go all the way around your circle, marking out the distance that you had with however many Smarties you had as your, or circular objects that you had as your radius. All right, so now with your circle being marked, okay, so we started here. Let me go into purple. No, purple, we'll go into red, okay? Or I started here. And so then I went, so this was 1, 2, 3, 4, 5, 6, and then we had just a little bit extra, right? Okay. And that should have been for everyone, no matter what you used as your circular object. You should have had 6 full radii and then 1 little part of a radii. Now, that little part is going to be dependent upon the size of your circular object. For mine, it was 2 because I was using 7. If you were using 4, it should be around just a little bit more than 1. Okay? So we got that. Okay? So we ended up with 6 sections plus some extra. Okay? So we're good there. What we actually just found is we actually just found a radian. Okay? So what we found here was a radian. A radian is the other unit of measure that we use primarily in trig. It's a degree measure. Okay? A radian is the angle, because remember, with trig functions, our input are angle measures. It's the angle needed to travel one radius on the circle. Okay. So this distance right here between numbers 3 and 4, that distance right there is equal to 1 radius. Okay. Which means, let me get my there. Let's pick a color. Let's go with like that. And okay. Which means then that this angle right here, that angle is 1 radian. That angle right there is 1 radian. Okay. Now, this extra part for me, okay, this extra part right here had 2 Smarties over 7 for a full radian. Okay? Well, the number 2 divided by 7 is equal to 0.28571. So all told, to go all the way around the circle, it would be 6.28 radians. Does that sound familiar to anyone? Yes, Joe, exactly. It's 2 pi. Okay? Okay? So it takes 2 pi radians to get all the way around the circle. Okay? So 2 pi radians, or 2 pi times the radius, is the circumference of the circle. Okay? And that's where that comes from. Okay? Love it, love it, love it. Okay? Now, the true mathematical definition of 1 radian is the measure of the central angle theta that intercepts an arc S equal in length to the radius r of the circle. Okay? So, what we mean by that is, if you had a compass, we could take said compass, we could measure out the radius of our circle, and then we could go and we could mark our circle like so. Now let me get rid of this. Okay. So we could mark that so that this here make that a little thicker. Mark now. Okay. That is my S. My arc length S. Thick red. Ack. Going this way. Didn't stand. Okay. So then this angle here would be theta. You can just sketch that if you need to. Do we have any guesses as to what the degree measure of 1 radian is? Okay. Degree measure of 1 radian. You can either unmute yourself with a guess, or you can type it into the chat. Degree measure of theta. Anyone? Just a guess. 35 or 40? Okay, what are we thinking? We agree with 35 or 40? Remember, okay, let me put a little extra in here for you. Remember that, so that would be 180 because it's straight, right? Which means that that is about 90. So what are we thinking now? Still going with 35 to 40? Anyone? I feel like the teacher in Ferris Bueller. Bueller. Around 60 now? Are we thinking a little bit more than 35 to 40? Okay. All right. The actual measure of an angle or of 1 radian, the actual measure is, now I got to use my cheat sheet, 57.2958 degrees. Okay. When S equals R, so when our arc length equals 1 radius, the way we got that is because now if we think about it, we've got 2 pi, right, to go all the way around our circle. In radians, 2 pi goes all the way around. In degrees, that same thing is 360 degrees. Okay? So if you take 360 and you divide it by 2 pi, oops, I forgot to open up my parentheses. 2 pi, you get 57.2957791. Okay? And that's the degree measure of 1 radian. Okay? We're going to expand off of that because we're going to need to use that to convert back and forth between degrees and radians. Okay? So, we said on the last one that 2 pi radians over, oops, I went almost over 180. There's 360 degrees in a full circle. Okay? Anybody notice anything about that fraction? Or if we flipped it over, so we got a scale factor going on. This is going back to when you were in geometry. Okay? Trig is a lot of geometry. It's an extension of it. Okay? Notice anything about that fraction? Or, let me rephrase that. Can we do anything with that fraction? Can we do anything with that fraction? Might be helpful for us. Anyway, what if I just selectively covered up the pi? Can we do anything with that fraction now? Divide them both by 2? Yes, we can simplify our fractions. Command Z. There we go. So the blue one would simplify to be pi radians over 180 degrees. The green one would be 180 degrees over pi radians. Again, it's all in how you're looking at things. Okay? So, if I am converting degrees into radians, okay, what I'm going to do is I am going to multiply my degree measure by pi over 180. And if possible, okay, we want to leave our radians in fraction form. So we want to leave it as possible, or if possible, in fraction form. So we might have something like pi over 6, or we might have something like 2 pi over 3, or something like 11 pi over 5, or 11 pi over 7, or something like that. Okay? We want to leave our answer in fraction form whenever possible. Okay? When we are going from radian into degree, then I am going to multiply by 180 over pi. Again, we like fraction form, but because we're in degree, that one we don't necessarily force the fractions. Okay? So when we're going into degree, we'll normally tell you what we want you to round off to. Okay? So, my question is this. Okay? Given this scenario, where the radius of my circle is 10 Smarties, and the arc length of my sector is 20 Smarties, what is the measure of my central angle? Let's call it theta. What would the measure of theta be? Again, you can either unmute yourself or you can type it in the chat. I'll take it in either degrees or radians. One of them is easier than the other. those of you playing along in the chat, I would even take it if you just held up fingers, too. Side note, I just gave you the answer. Refreshing our memories. A radian is the distance on the circle, that circle. I don't get the on. Distance on the circle to go 1 radius. So if my radius is 10 and my arc length is 20, how many radians did I go? If my radius is 10, so this distance here is 10, and this distance here is 20, how many 10s did I go on my circle? 2. Yep. So theta here is 2 radians. Okay. Because 1 radian would be 10 Smarties on the circle. Okay. We went 20, so we went 2 radians, which is approximately 114 degrees. Okay. This formula is something that you should commit to memory. Okay? The arc length, S, is equal to theta times your radius. And there's one condition, and that condition is theta must be in radians. Then we can offshoot that formula. So we have arc length equals theta times r, or theta is equal to arc length divided by the radius, or we have the radius is the arc length. Oops, I got bad S on that one. Divided by theta. Depending on what we're solving for in that particular problem. But it always ends up, or all comes from theta times radius is my arc length, provided that theta is in radians. Okay? Question of the day today, since we would have been eating candy here in class, what is your favorite kind of candy in the chat? What is your favorite kind of candy in the chat? Okay? With that being said, or type that in there while I talk to you a little bit here about toward the end of class. Yesterday was the due date for the Chapter 3 test. There are still some people that need to complete that assessment. Okay? You are going to need to contact your grading teacher to determine how and when you are going to do that. I also have multiple people just in my class. I have multiple people that have yet to turn in the review assignment and the other homework from Chapter 3 the exponential and logarithmic worksheet. Okay? So I'm missing, between those two, I'm missing over 20 of those from students. Okay? Get those in ASAP. Okay? Because it's the end of the quarter, that's why. Plus it's conferences today, and some people have parents virtually or phone or coming in for conferences. So make sure that you get that done and have that so that mom and dad don't say, hey, why don't you have these 2 assignments in for pre-calc? And I'll say, oh, okay. That's all I got for you today. Thanks for playing along. Sorry that it was so long today, but we had to get through the Smartie activity, and normally at this time we'd be sitting around chatting, eating Smarties, and having a good time. So, okay. Have yourselves a great, grand, and wonderful day. We'll see you tomorrow.